Good morning, student. Myself, Dr. Govind Sharma, Assistant Professor Mathematics. Now we are continuing with the linear algebra series, the linear equation system. Yesterday we discussed about the matrix form of linear transformation. So today we will continue with this topic and do the numerical problem on basis of this topic. The objective of the to know about the linear equation, linear property. So we move to the our lecture. Yes. In previous lecture, we discussed the matrix representation of linear transform. Now, in linear transformation, how we can write it? I told that E2, the basis of E2 are usual bases are 1, 0, 0. Basis of E3, you can usual basis 1, 0, 0, 0, 1, 0, or 0, 0. Now, find the matrix form of P P x1 x2 is equal to x1 plus 2 x2 x1 minus x2. So first we take T from A2 to A2. So we write the matrix form, the solution. First we take 1, 0, the usual basis 1, 0. So put x1 here, x1 is equal to 0 and x2 is equal to, x1 is equal to 1 and x2 is equal to 0. So put value in this x1 plus 2 x2, x1 minus x2. So put x1 is equal to 1 plus x2 is equal to 0. So this becomes 0. 1 minus 0. So it will get 1. Now again T01. So x1 is equal to 0 plus x2 is equal to 1, 0 minus. So we get 2 minus 1. So the matrix form of this is the transpose of 1, 1. We can write like that 1, 1, 0, 0 plus 1, 0. Sorry, A2 1 1 0 plus 1 0. We can write 2 1 0 minus 1 0 because this is also E2. So we can write 1 1 2 minus. This is the metric form of. Now we take another example where when basis was not basis, the bases are given. So let bases are P R S to tau, the basis of S and T to R 3 minus 1 1 2 3 minus 1 1 and T is equal to x1 x2 is equal to same x1 plus 2 x2 x1 minus. Now the solution convert in the matrix form or can write in the matrix form. So to x1 और हम करेंगे t first basis 3 minus 1. This should become 2x2 x1 minus. Here x1 is equal to 3 or x2 is equal to minus 1. 3 plus, so this will become 1 and 4. And now this is the E2. We can write alpha is equal to 3 minus 1 plus beta is equal to 1. This. Now second P12. So we get 1 plus 4, 1 minus 2. So we get 5 minus 1. 5 minus can write as 3 minus 1 plus beta. Now we have to find out the value of alpha and beta. So 3 alpha plus beta from 1 we get is equal to 1. For equation 1 we find and from 1. And minus alpha plus 2. Here we take alpha 1 and beta 1. So this is not be confused to you. And 3 alpha 1 minus alpha 3 alpha 1 plus beta 1 is equal to 5 and minus alpha 1 plus 2 beta 1 is equal to 3 and 4. So first we find out alpha and beta. So 3 alpha plus beta is equal to 1 and minus alpha plus 2 beta is equal to. Multiply this equation by 2 and add and subtract. So subtraction, this is sign change. So 2 alpha cancel 6 alpha plus 1, 7 alpha. This beta is cancelled. 2 alpha is equal to minus. Subtract. So alpha is equal to, we get alpha is equal to minus 2 by 7. Now value of beta, we put the value in this equation. So alpha is equal to 2 by 7 plus 2 beta is equal to 4. So 2 beta is equal to 4 minus 2 by 7 means 26 by 7 is equal to beta, and beta is equal to 13 by. Now alpha 1 and beta 1 value, how do we find out? Now 3 alpha 1 plus beta 1 is equal to 5, and minus alpha 1 plus 2 beta 1 minus 1. So multiply by 2 and then add, then subtract, plus minus plus. So 4 alpha 1, sorry, 6 and 7 alpha 1. This is cancel, 10 plus 11. So alpha 1 is equal to 11 by, and beta 1 minus 11 by 7 plus 2 beta 1 is equal to minus 1. So implies 2 beta 1 is equal to minus 1 plus 11 by 7. 4 by 7, 2 beta 1 implies beta 1 is equal to 2 by. So alpha beta and alpha 1 beta 1 value we put, so by equation 1, by equation 1 and 2. So by equation 1, 1 4 can be written as linear combination of alpha value. What is the alpha value? Alpha value is 2 minus 2 by 7 minus 2 by 7 1 0, and beta value is, what is the value of beta? 13 by 7 plus 13 by 7 0, and 5 minus 1 can be written as 5 minus 1 is written as 11 by 7 1 0 plus 2 by 7. So the matrix form empty can be written as the basis multiplier of basis 2 by 7 transpose of this is the matrix form of, this is the matrix, this is the, this is the matrix form of transformation. Now these two examples, one is the linear combination of usual basis, and second is the bases are given. Now we do another example. Another example that same method we apply. Now we take another example. When the bases are different. So the bases are different. So T are given as to 2. The basis of f are given like 1 minus 1 1 1, 1 minus 1 and 1 1. And basis of 2 are given 1 0 0 minus 1, 1 0 0 minus. And t is the same, x1 x2 is equal to x1 plus 2 x2 x1 minus. This is our t. So again we apply the same method, but transform the, so we transfer. First we take t 1 minus 0, 1 x1 is equal to 1 plus 2 minus 1, 1 minus 1. So this is become minus 1. It can be written as in the form of alpha 1 0 plus beta 0 minus. So here we first find out the alpha beta. So minus 1 is equal to alpha plus beta 0. So alpha is equal to minus 1 and 2 is equal to minus beta. So beta is equal to minus. Minus. So we can write minus 1 1 0. This is our equation first. Same t 1 1 x1 plus 2 x2 x1 minus. So this become 3. Actually we can write the value 1 plus 2 and 1 minus 1 is equal to 3 0. 3 0. It become alpha. The basis of T are basis of S are alpha 1 0 minus 2 0 minus 1. So with the comparison 3 is equal to alpha, yeah, taken beta, beta. Alpha is equal to, and beta is equal to 0. So we can write 30 as 310 minus 0 2. So matrix representation of this mt is equal to mt is equal to transform or the basis, so become from 1 and 2, from 1 and 2 we get minus 1 and 2, 3. This is the matrix form of linear transformation. So I hope we have used the three basis form here apply. First, when we use the usual basis, then the both image and domain both have the same basis, and third the different basis. So this is more comfortable for understand the further concept. Now we move a good question. Let T is the mapping from P1 to P2. We define as defined by Ta plus Tx, Ta plus Bx is equal to Ax plus P by 2x. P1, P2 are the standard basis. P1 and P2 are have basis S and T. S and 2. S is equal to 1x and tau is equal to 1x. So represent in matrix form. Now, first we take in the form of the S is the basis given 1 and x, and 2 is given 1x, 1 and x, 1x x2. This is from V1 to V2. So, first the given we compare T0, T1 taken from S. We can write T as 1 plus 0x. Here b is equal to 0. So we get here x and b is equal to 0. X. And it can be written as in this form of basis 0 dot 1 1 dot x plus 0 dot. This form can be written in tau basis because basis of tau is 1 x square. So we have to write the solution in the form of 1 x square. So here plus x plus 0 because b is 0 and a is equal to 1. So become x plus 0 x square. So 0 it converts 0. So you get t1 plus 1 is converted in the x. This is our first. Now tx we can write as tx as a0 plus b1 x. This is our in t basis. In the t basis, which if first write the basis in the t basis, then convert in the tau basis. Sorry, s basis. This is the s basis. A plus bx. So a is equal to 0 because we want to write here x. So it is 0 plus 1 dot x. So now we can write 0 plus x. So a is equal to 0. A is equal to 0 plus b is equal to 1 and this is x. So we get here half. Now we write half x square in the form of tau basis. Tau basis is 1 x square, so 1 dot 0 0 x plus half x. This is our. So now the matrix form MT is equal to the transpose of this matrix. So 0 1 0 1 0 0. This is our transpose of matrix. This is our matrix of linear transformation. So this is very important concept to how to write a matrix, a linear transformation in the form of matrix. Now we move in little tough example. Now P from P2 to P1. A plus bx plus a plus bx g plus 2cx. So find the matrix. Here again bases are the same. Bases are the same. This is from tau to P2 bases are tau So bases are 1x x square and s bases are 1 and x. So we take element from 1 from tau basis. It can be write as 1 plus 0x plus 0 x square. So here b is equal to 0. So c is equal to 0. So this is converting 0. Now we write in the form of this 1 and 0. 0x. This is our one equation. Now x. It can be write as 0 1 dot x plus 0 x square. So b is equal to 1 here. So 1 plus 0 x. This is equal to become 1. It can be written as in the basis form 1 dot 1 plus 0 and 2. Basis of s. Now t x square we can write as 0 plus 0 x plus cx square 1 x square. This will give us b is equal to 0 to c is equal to 1 here and x square is equal to 2x. So it can be written as 2x, sorry, 2bx. So this is converting to x form. So we can write 0 1 plus 2a. So now the matrix representation of LT is the transpose of is the simply transpose of matrix made by the linear combination of 0 0. The transpose is 0 0 1 0 0 2. This is the matrix form and the order of matrix is 2 into because here row is number of rows is 2 1 and 2 and column are 3. So this is the matrix form of. Now we can also check that this is invertible or not. This is invertible So there we get a one row is 0. So this is not singular matrix. This is not singular. Singular matrix. This is a singular matrix because one column is 0 here. So it is not inverted. Again I explain this question. The question is first given that the transformation from P1 to P2 we define as Tax plus Bx. Actually this domain have the basis S 1 and x, and this codomain have the basis 1x x square. So we take first from the domain T1. So T1 how we can write T1 plus 0x because is a b is equal to 0, a is the constant term 1, 1 plus, and b is equal to 0, b is 0 dot x. So it convert in the form of x plus bx here upon 2. So it can be write as it can be written as 1 plus, so a is equal to 1, a is equal to 1 here, 1 dot x, or b is equal to 0, so it get plus 0. So we get here x, and x can be written as the linear combination of this basis of 0 dot 1 plus 1 dot x plus 0 dot x. Similarly, we taken the second element x from S basis. So it can be written as here b is equal to 1. So a is equal to 0 and b is equal to 1. So 0 plus 1 dot x. It can be written as x as you can be written as this form of x basis and 0 dot x plus half x square. So it gets half x square. So half x square can be written as 1 dot 0 plus 0 dot x plus half. And now we transform the matrix. We make the matrix of the linear combination and we transpose. So this is the matrix we get after the transfer. So I hope today we have done the very much example of matrix transformation. Now we move to our some quiz question. What type of question waiting for us in today's quiz? Which is the correct statement? Rank of matrix always greater than order. Rank is always less than the order. None and both. So rank of always greater than order, this is wrong because I told you a theorem that rank plus nullity is equal to order. So never be rank of a matrix be greater than the order of the matrix. So B is the right option. Rank is always less than the order, or we can say the correct statement is rank is always less or equal to the maybe equal to the order. So B is the right option here. Which are the usual basis of E2? Usual basis are the standard basis I told you when the lecture started. So 1 0 and 0 1 are the usual basis for the E2. So B is the right option. What is the nullity of matrix? Nullity is the image of the wrong, image of the not image of the dimension, dimension of kernel vector, dimension of range T. So dimension of range T is called rank. So nullity is the dimension of kernel vector. So here also B is the right option. Which are the usual basis of E3? So here when we discuss about E2 we get 1 0 and 0 1. Here we get 1 0 0 0 1 0 and 0 1 0 0 1 are the usual basis of E3. Which is true statement? Identity operator is additive, that's right, and zero transformation is also linear. So both are the right option. So A and B both are the right. So D is the correct option. So I hope students are today we have taken more examples. So this is clear. So thank you very much.